This is the Microsoft Cloud Show, episode 158. In this episode, we're going to talk to Mark Fussell from Microsoft about Service Fabric in Azure. Recorded live September the 28th, 2016.
Welcome to the Microsoft Cloud Show, the only place to stay up to date on everything going on in the Microsoft Cloud world, including Microsoft Azure, Office 365, SharePoint, and the competitive landscape and related technologies. Just the information, no marketing, no BS. I'm Andrew Connell.
And I'm Chris Johnson.
Send us a tweet either to the show at MS Cloud Show or to Andrew at Andrew Connell.
Or Chris at LoungeFlyZ.
As we'd love to connect with you. We're just two dudes telling you how we see it.
Hello, everybody. This is Andrew Connell again. In this episode, I sat down with Mark Fussell from Microsoft to talk about Service Fabric. Service Fabric is a product that Microsoft announced back at Build of 2015, and this is something that Microsoft has been running inside of Azure for many years, and actually hosts many Azure services, including services like DocumentDB. They use it to go through and to manage their entire infrastructure, to manage their different applications, their different services, and it really, as you'll hear Mark say, is one of the first true orchestrators out there. There's been a lot of stuff that's happened with Service Fabric since they announced it, including some announcements from this past week at the Ignite conference, where you hear me recording this live from the expo floor. This is an AC and a CJ episode. I sat down with Mark just a few minutes ago and wanted to get this episode out to everybody as quick as we could. So I'm going to go ahead and play the episode and hope you enjoy it. All right, this is Andrew Connell again. I'm sitting here on the expo floor, as you can tell with the background noise, at the Ignite conference in Atlanta, Georgia. I'm sitting here talking with Mark Fussell. Mark, how are you doing today?
I'm doing great. It's fantastic to be here at Ignite. There's a lot of excitement happening.
Oh, there really is. And you had a session earlier today, didn't you?
Yes. I just finished it now. In fact, we just come off the floor talking about Service Fabric and how it fits in with microservices concept and how we're using that to build services ourselves in Azure.
Awesome. So Service Fabric is something that we wanted to talk about on the show for quite some time. But before we dive into there, I want to give you an opportunity to introduce yourself and let our listeners know, who is Mark. And we're going to, towards the end, we'll actually point to a lot of videos and additional content too, where if we haven't covered it in this first discussion, then they can go find additional information, both stuff that's been recorded and stuff that's coming up later on in November. But then, and also for our listeners, if there's anything in this that you want to dive deeper on and stuff like that, Mark and I have talked about it, and we can definitely get back on and do future episodes where we get a little bit deeper into this. This is a massive topic. This is not something you can bite off in 30 minutes or an hour, but we're going to do our best.
Yeah, we're going to do our best.
Yeah. So, Mark, why don't you introduce yourself to our listeners?
Well, so I'm Mark Fussell. I'm a program manager that works on the Azure Service Fabric team. That's part of the core Azure team. I worked on Service Fabric for a number of years. In fact, I kind of helped kickstart the project back in 2009. So I've been a long-term kind of participant on the project and helped kind of bring it from an internal project where we used it to build our own services to externally now when we give it to customers. So I'm sort of thrilled to be here and can talk about everything from the history all up to the new future of what we're doing now and the roadmap we're going forward.
Awesome. So I know you've been working with Service Fabric since its beginning, right? I guess so for quite a while now. And I recently sat down and I watched all three of the Cloud Cover episodes that you had that came out. I think it was earlier in September.
Yes.
Of September 2016 for people who listen to this in the future, where you guys, it was very much like a 101 style of it, and then how it going through and building some stuff that was building some stuff that was going to run in Service Fabric, and you talked a little bit about containers and Linux containers. But really, before we go into all of that, one of the things why don't you tell us a little bit about what is Service Fabric? How does Microsoft use it? And then we'll start talking a little bit about like the microservices style architecture, and then get into more of the details about Service Fabric itself.
Okay. Well, so at its heart, I kind of sort of think of Service Fabric as we call it as a microservices platform, but it's also an application server. And it allows you to build your applications and distribute those across a set of machines. The history of it is, we built Service Fabric for our own needs when we started to build lots of services over the years. We started a project called Cloud Database, which was bringing SQL Server to the cloud to host relational databases. And when we did that, we understood and started to learn lots of things about how you have to build an app to be deployed across lots of machines, what was the development model around it all, and particularly the life cycle of how we roll out changes and make sure we do continuous deployments and agility around these services that we built. So as we learned from all of those, we realized that we had to have a platform for our own services to build upon. We didn't want to have all the pain and tension of just using a single set of VMs underneath it all. What's the application platform you want to build on top of that? And interestingly, as we did all of that, this other term started to emerge inside the industry where people started to talk about microservices. And we looked at that, and we looked at what we built, and we went, wow, they're kind of like this sort of similar sort of thing in terms of what we're doing.
Right.
And really what was driving it all was that as we built our services, we were taking a lot of our existing box products, things like Skype for Business, for example, and hosting those in the cloud, and realizing as we did that, we had to deal with a distributed systems problem. What that turned out to is one of two things. It's either usually an ability of how you're going to scale your service, so how I scale it out from a few machines to thousands of machines at some point. And then there's the agility around all this. How is it that I can take an application and I'm continuously evolving it over time, adding new features, fixing bugs, making sure I provide new capabilities all the time. And so those things drove us of how to build Service Fabric as a platform. So at its heart, there's this platform that does all sorts of capabilities for you. It allows you to deploy a set of processes or containers across a set of machines, so it's an orchestrator of those. It builds a cluster, and your cluster can shrink and grow in size of your resources around that. It allows you to take application packages and deploy them into that cluster of machines, and it does it very efficiently because it can understand things like the amount of resources and a particular application uses. It understands the capabilities of a particular machine inside the cluster and matches those things up. It deals with failover, so machines die. Often in the cloud, you don't actually own the machines.
Right.
And so the problem was that traditionally people go, oh, look, that's my database server, or there's my middle tier server, and I can point to the thing. Well, sort of in the cloud, you tend to have this more dynamic pool of machines, this cluster of machines. And so as you start to go to that model, machines die, processors die. You want something to make decisions for you about how it self-heals the system, does a recovery of it, recovers whether what machine died, what was running on that machine, how should I go and then distribute that code onto the other remaining machines. And then telemetry information. We found more than anything was that you had to get rich diagnostics, telemetry, health out of the system. And the health particularly started to roll into a whole feature where we thought about how we do rolling upgrades in the DevOps side of things. It turns out that managing a service is as hard as actually building the service. And we get a lot of people, and even Microsoft made this mistake. We built a lot of technology that helped you build your service, but we sort of left you behind in the DevOps world afterwards about, okay, what does it mean to roll out a new version? Or if I roll out a version that's got bugs in it, how do I do a health check on that thing so that I understand that, say the process failed to come up 3 times or X number of times, I can roll it back to the previous version and do it in a fully consistent way. So I'm not left with half my machines running version 1, half version 2, and I'm in a confused, difficult world. So that whole guaranteed rollout and downtime was another core feature.
I see. So it's funny you say that. I mean, a lot of the stuff that you're talking about, a lot of things that Microsoft figured out and stuff, you're starting to see a lot of people in the industry talking about it across all these different options that are out there. I mean, Service Fabric can do the health check. You saw back in June, like Docker introduced on their Docker 1.12 platform, they introduced the health check as well to their stuff. Yes. I know like Kubernetes does it as well. Mesos has got a whole model to it too. But it's interesting how everybody is starting to figure out the same kind of stuff, and everyone's trying to come up with different solutions for it. So now you talk more about like a microservices bit, where it's not so much. It's funny because a lot of our listeners, when you first start hearing microservices, a lot of people first think like ASMX style web services, and it's a service, like a database is a service, or an application service. It's really just it's a process. It's a process that's running that's just self-contained, right?
Yes.
So. How do you look at microservices? How do you look at building a microservice-based application architecture where things are kind of broken up into different pieces and such? What are the main components that kind of say that smells like microservice to me?
Well, at first there's to answer that question, that's quite a complex question to answer, but it comes down to, I think, 2 things. There's the microservices approach where you're finding particular domains inside your application. And domains are areas of capabilities and functionality that you can self-contain. So it could be anything from just a cache service by itself to a workflow business process to some other database service that runs over here. And you can isolate those all together and say that's a unit of functionality. Often they're sort of go along org boundaries as well in terms of what they look like. What actually happens is that there's a pure definition in some ways for what just a microservice is. We tend to think of it as a self-contained piece of code that can be versioned, upgraded, and scaled by itself. Mm-hmm. And usually you talk to over known protocols like REST or some contract over it. Mm-hmm. So that's kind of like what it is. Mm-hmm. How you divide up your project into those things is a bit more complex. Certainly when we see people build applications in Service Fabric, they take often sort of a monolithic set of processes. And whereas before they sort of made more component boundaries between things, and you'd use linkers and compiler checkers to get componentization, you tend to sort of break those components apart now into individual services with contracts between them all. And so, some of the examples around all this is, we have a lot of IoT examples, people who built IoT systems on top of us. And they look at it and they tend to have a gateway microservice that sits at the front that does all of the device management inside there. And then they might have the actual device service itself that manages all the devices for a particular customer. And then they tend to divide those up. I might have a service that runs on a per customer's basis. And then, invariably, Service Fabric itself doesn't sit isolated. We will use back-end storage technology to be able to write your data, or we use things like Active Directory for authentication checking, or even event hubs for sending data between machines. So it's very much a technology where you build your apps that sit in the middle. So I would say that those are surrounding systems that also constitute part of your app. But breaking the microservice itself down tends to be around taking those process boundaries and putting network boundaries on top of them.
Gotcha. And so, in a lot of the times, the services don't have it's very loosely coupled, right? So we don't have things this is what facilitates the things of the rolling updates, or facilitates making sure that you can scale them independently of each other. And I know one of the things that we can do too that does make that work really well is to have everything talk to each other through a messaging style of infrastructure, instead of just having a direct call straight in. We can do the direct calls, but messaging is another way, where pop something on a queue and have it be published out to one or more different services that are listening for that.
Yeah, and so one of the things we do to help with that in Service Fabric is, for example, that we've built in a thing called a reverse proxy class, and there's a reverse proxy service inside there where you can use simple URLs. So Service Fabric helps here because every time you build a microservice and deploy it into the cluster, every single of those microservices is uniquely identified with a unique name for that particular instance. And you can then communicate because you can identify, just like you have DNS for the web, you sort of have this naming service that does DNS for all of the named microservices that run inside your cluster. And then a reverse proxy allows you simply to do a URL format to go this service, this instance, and call seamlessly between these things. So providing that sort of communication stack between them all. And then we also get a lot of requests and asks that we're looking at is how do I do a sort of a pub sub mechanism as well, where I can listen on another service and get notification events about when it does things on my service. And that's something that we're looking at how we build and enhance that messaging stack. But yes, very much the protocols between the services. Service Fabric, by the way, is protocol agnostic. Whether you use HTTP or TCP, that's up to your choice. But then we help with the fact that you want to find and discover those services inside a cluster and communicate with them over known endpoints.
I see. Okay. So, and another thing too, just to clarify for our listeners too, Service Fabric is not something where I'm going to bring my application and I'm just going to drop it in and say it's going to work. This is an architectural style that you're going to decide on pretty early, that you want to build something and you want to rely on something like Service Fabric. So Service Fabric gives us a couple different ways of things, different templates, I guess you could say, of ways that we can build our application. There's stateful services, there's stateless services. I know there's something about the actor model. So could you talk a little bit about what these things are and how people would actually use them?
Yeah, so we wanted to very much focus on the developer productivity of how they built applications. And so we wanted to provide some frameworks out of the box that enabled you to build those applications rapidly along a microservices style. We should also talk about how it means to migrate to a microservices style and what it looks like. But certainly when you start to build new services, we provided these 2 out-of-the-box programming models. Actually, I'd even say 3, because I'd include ASP.NET Core inside there as well. But the ones that we build inside our team is one called Reliable Services and another one called Reliable Actors. Reliable Services is a very interesting stack that we start off with because it provides this concept of stateless and stateful services. The stateless is, if you're very familiar with cloud services, it's just like a piece of code that starts up, it runs, and normally your state is externalized somewhere else, and you download that state, say from Azure Table Storage or from SQL Azure databases, and then you load up that state and run in a very classic sense. We build many, many services like that. Gateway services, where messages come in and just get routed, are very classic. People already have some existing data, they just want to load up and process it. But Reliable Services also does a very unique thing, I think, to Service Fabric that truly differentiates it from other platforms, and that is stateful services. And what we did there is, as we built more and more of our services, we realized that there was a lot of need to have the data and the compute co-located on the same machine. And we wanted to do that mostly because of latency issues. Actually, it turns out to be latency issues as well as simplicity of design. We found that a lot of requests came in, and let's go back to that simple IoT scenario. Say you have 1 million devices. You take the data from 1 million devices and you put it all into a back-end store. And then you want to ask the question, well, what device have I not heard from in the last 5 minutes? You have to load up all the data from 1 million devices, look through every single one of those, find out ones you haven't heard from, and it's very network intensive, dragging all that data back. In the Service Fabric world, well, all that data for a particular device is located on the same machine. In fact, Service Fabric is also a storage technology. We write all the data onto the local machine. You have a stateful service where the data and the compute are co-located on the same machine, and you can scale that out together. And so we build these very innovative systems now where you have low latency, bring back the data, you have the data and compute together. In fact, most of the time when someone says, I build a cache in my system, for us we immediately go, that's a stateful service. Because you're trying to have this data close to your compute. A cache helps with the read latencies, it doesn't help with the write. And when we look at those systems that want caches, stateful services provide exactly the same approach, but you get improved write latencies around them all. And importantly, inside Service Fabric, because it's a storage technology, it's fully guaranteed the consistency of that data. You can keep your data there for years and it won't be lost.
Okay, so that was where I was going with this. We talked a little bit about how you want to be able to scale this out very easily with a microservice, but you have the data tied to the data in the compute tied together on the machine. If I start scaling that out, what's the story then if the machine goes down under the covers and stuff? Like, how does that? Is the state still replicated? Is it kept in multiple places? Like similar how with SQL Server, you have the triple commit that happens, and that if one of the Azure SQL databases goes down, you've always got it back up in some other location. How does Service Fabric handle that, and does it handle it?
Well, that's exactly. So we spent many years building a fully consistent replication technology, where as far as your developer is concerned, all you deal with is some data structures like dictionary and queue that are very familiar with you. But under the covers, we take that data and we replicate it onto other machines. So when I write into my dictionary, I'm actually making replica copies on the current machine, on 2 other machines. In fact, it's a quorum-based ACK system. So we make sure you can have, say, 3 copies of your data, 4 copies, 5 copies of your data. The more copies you have, the more resilient it becomes. But being a quorum-based ACK system, we send off messages to each one of the other secondary replicas. When a quorum has come back, which is a minimum set to say, I've got a definite, consistent copy of this stored on another machine, then we act back to the client. So, for example, a classic one is that you build a 3 replica set for your data. You send off ACKs to the 2 secondaries running on other machines. When one of them comes back as a quorum ACK, you write to your local one. So you've got the primary, you've got the secondary. That's your 2 quorum ACKs out of your 3 quorum system. You can act back to your client. At that point in time, if the primary fails, you've got a secondary backup.
Right.
And in Service Fabric, there's all the intelligence of what we do called leader election, where the machine dies. We know exactly now what machine to fail over to. We go to the machine with a consistent set of data, turn that into the primary, hook up all your clients to point to that thing again, and all of this is completely transparent to you. So those replication consistent protocols are all handled in the event of machine failures, process failures, network failures. And the thing that you have to be very clear on this is it's a fully consistent system, where like consistency in ACID, we make sure that there's a replica copy of your data held securely, resiliently, and persistently on another machine. So, in other words, we have people who build transactional trading systems on top of us. It's not an eventually consistent system where I might have a copy of my data and it might be 3 days old or 3 seconds old. We'll make sure that there's guarantees around that.
I see. So we talked a little bit about how we have like the different ways that we can build stuff today, and there's another model that you have is an actor model, which it's when I first heard about this, it seemed very unique, but it makes a lot of sense for a lot of different scenarios. Can you talk a little bit about what this actor model is?
Yeah, so once we had built this reliable services layer, which had these distributed data structures, we then realized that there was another level of abstraction and innovation we could go to, which was actors. And the actor model is it's actually, I wouldn't say it's unique to Service Fabric, it's a thing from the 70s that we've just sort of revitalized, I would say, and I would say it's got revitalized in the cloud era. But what an actor is it's a piece of code and data together where you have a set of methods on your data. So going back to the IoT scenario, an actor might be like a device. It's got some state with it, its current temperature, and it's got some methods. Get temperature, set temperature. And the unique thing about Service Fabric is you can create thousands, tens of thousands, millions of these actors. They all have just a unique ID. And so from a developer perspective, you just say, create me an actor. I want an actor for a person or for a car or for a healthcare account or whatever you want. You can identify it as a unique ID, and then we store it across the distributed set of machines for you, and we'll retrieve that thing for you. And intriguingly, the direction that we went was we create this thing called virtualized actors, where at any point in time you can go and create this actor, and it always exists and lives. And then, a bit like garbage collecting inside .NET CLR, after some period of time hasn't been touched, will persist its state away. But if you go off and say, I want to get actor 1, 2, 3 again, we'll create this thing on a particular machine and send all your traffic to it all.
Oh, okay.
So the beauty of it is that in particular scenarios where you want very isolated sets of code and data, it's just like it's just like an object. Give me the object that runs inside distributed system. It's running on X number of machines, but I don't see the machines, I don't see the cluster, I don't see anything. I just deal with my data, code, running inside the cluster of machines.
I see. That's interesting. Yeah, it's a different model. So you could have like an actor of like if I was going to be building a system that was going to manage like a fleet of cars, like a car could be an actor because it'd have lots of different. Each car would be a separate instance within the system.
Yes, in fact, BMW built an exact system like this. There's a use case study that we posted on our site where they had an actor that represented the driver and an actor that represented the car. And so when you log onto their system, it creates an actor for you as a driver, and it tracks where you are in your current location, and it tracks your car, and they modeled it in that way. And so now they can build their application on top of it all.
Oh, that's really interesting. I saw another option too that seems relatively recent as well, is the ability to do containers on inside of Service Fabric. Can you talk a little bit about that?
Well, yes, so Service Fabric has always been an orchestrator. So we take a set of machines, deploy a set of processes across it all, and activate a set of code around them all. When we first came out with Service Fabric, we wanted to focus particularly on the fact that we had these higher level programming models to help you be efficient around how you build your applications. But we also recognized that containers is a way of taking some existing code and putting it into these containers and deploying those as another way of building microservices. So with the advent particularly of containers, now in Windows Server 2016, you can walk up to Service Fabric and just say, well, I've got an existing app that I want to put inside your container. It might be a new app like Node.js application. One thing that we're seeing very common is people are taking IIS applications, IIS, ASP.NET, MVC applications, and containerizing those, and then just saying, oh look, Service Fabric, launch these 20 containers with IIS running inside them all, and launch these existing MVC applications, and we'll do all of that for you. So you've got this blended world. You can take our programming models and use them if you want. You can take a Windows container and deploy all of that. And then we allow a thing as well just called guest executables, which is just a piece of code. And
that's just like a console app, like a .exe.
That's just like a .exe, yes. I mean, we actually, although containerization is a great way of packaging, as I said, binaries and things together, we also just say, if you want to launch a process, it's even quicker than a container. And then we actually launch even pieces of code inside that. So processes and that sense gives you even higher density around these things. But the good thing is, it's not you necessarily have to choose. You can bring in, for example, we have a company who built a gaming application, and they downloaded Nginx container, raw form, onto the Service Fabric cluster as their front end, and then used our Service Fabric actor to build their back-end services around all that. So they mixed a container world with Nginx and our programming models with the actor programming model to represent their code and deployed that all as a single application.
That's really interesting. So it's a big mix of a bunch of different things right there. That's cool. You also said something about an orchestrator right there, and I know that's a hot term in this microservices world and containers and everything this year. It seems like this is the rise of all the orchestration tools with things like Kubernetes, things like Mesos, things like Docker Swarm and everything. I'm curious because I know when I first saw. We talked a little bit about this, before we started recording. But when I first saw that Service Fabric could host containers as well,
yes.
I first started kind of like cocked my head a little bit, and I'm like, so this seems like it's another one of these different options here. And we were talking a little bit about how Google's come up with theirs, and Google has you've got the Google Borg engine, which is what runs all of Google, and then they created another open source project that they use to host their customer-facing container host, which is also open source. This is all Kubernetes. You made some interesting comments around this on how you kind of look at this too. I found that really interesting. If you share that with our listeners.
Yeah, I can share that with you. Yes, I mean, primarily Service Fabric is an orchestrator. Right. It's the orchestrator that we built in Microsoft to build all our services. We built it over many years, even before the rise of Docker and containers inside the industry. We were orchestrating deployments across many sets of machines like this. Google does the same. They have their Borg engine. They do all of that. One of the differences, I think, between those two is that Google has a lot of technology internally, and when they ship externally with Kubernetes, they were different things.
Yeah.
Service Fabric to us is actually what we run our services on. So we built Service Fabric for ourselves. I'll be blatant about it. We built it to build our own services first. We always had an intention of shipping it externally, but we use it to build Azure databases, DocDB, Event Hubs, IoT Hub, Intune, huge numbers of services. Backend of Cortana runs on all this. But what we're also excited about is actually we take the same bits and give them out to the rest of the world. So just before we do a release and roll it all out, we've rolled out Service Fabric to thousands of machines where Azure Databases is running, DocDB is running. We've tested it on all those machines, and we've tested it on our own. Even core parts of Azure, if you're familiar with the Azure resource providers and that model, the compute resource provider, network resource provider, and all those runs on Service Fabric. So we tested all of these systems first, and then once those are tested, we then give you out the same bits. So you literally get the same bits that have been rolled out across services we run a few weeks later from having rolled out across our systems.
So I'm sorry, go ahead.
So I'm just saying I think there's a big differential there.
Yeah.
Now, the other thing that we're doing with Service Fabric is making it come to Linux world as well. I think
that's where it gets. So going back to that real quick, because I definitely want to get to the Linux bit. So you're saying that it's probably a fair comparison that you look at what Google's Borg is to what Service Fabric. Kubernetes is the consumer version of Borg, but you guys don't. You just said no. We're just going to give you what we use. This is the same thing that we use to run all of our stuff.
Exactly. Yes. That's what we effectively did. You could certainly draw parallels between Service Fabric and Google's Borg in terms of as a distributed systems platform of how you do that. And then we gave it exactly out in its raw form as it stands, both for you to run in Azure and how we host it as a service, and also for the same bits that you can take and just take a set of Windows machines as it stands today, or a set of your own machines, and deploy it there and run it inside your own data center. So we want you to be able to take this and run it anywhere, both in Azure, on-premise, and we even have a customer today who has Service Fabric running in production on Amazon.
Oh, do you really? That's interesting. Yeah, because the Service Fabric is it part of the Azure Stack, or is it something totally separate that you don't need Azure Stack to actually do Service Fabric to be able to stand it up on different machines?
Well, so one of our announcements at Ignite this time was that we announced what we call Service Fabric for Windows Server, and it just allows you, just like how you take .NET and install it on a set of machines yourself, you can just take Service Fabric and install it on a set of Windows Server machines yourself. Take some boxes, put a network cable between them all, run a PowerShell command on one of them, it copies Service Fabric to the other machines inside the cluster, builds a cluster for you. So you can just have standalone Windows Server machines. Now, Service Fabric will be included in Azure Stack, not only just for the programming model, but because other services in Azure Stack depend on Service Fabric. So there's both things inside that model as well. But as it stands right now, one of the exciting things we have is that, yes, you don't have to wait for Azure Stack in order to use Service Fabric on-premise. And we're getting a lot of excitement around this from those companies who want to build their apps because they want to keep them inside their on-premise data centers because of data sovereignty, or just because they like their existing framework they want to run and build it on top of Service Fabric, or any other reason, just existing test infrastructure that they have. Over time, of course, they might move them to Azure, or we can't prevent anyone from going off and running on other cloud providers. But it's a platform we want to have available everywhere. And as I said, on Windows and now on Linux.
Yeah, so and you mentioned that too on Linux. I saw that you talked about this in your Cloud Cover episodes earlier this month. So everything we've talked about, that was all. It seemed like it was all a lot of it was mostly Windows, or at least that's where it all came from. But now you can do all of the same stuff on Linux. Is there anything that's kind of like a differentiator between what I can do on Windows, what I can't do, what I can do on Linux, or vice versa? Or is it all just it's across the board? It's just you choose your platform.
Well, that's where we're eventually going to get to. I don't think we're there just yet. I mean, at the moment, the Windows is more advanced. The whole platform is almost entirely built in C++. So porting it all over to Linux, wasn't too hard for us. But there's still differences between the two. I mean, there's capabilities on the Windows side, for example. We integrate with Active Directory over there. And we integrate with other Windows features. Well, we have to find those equivalents on the Linux side. And as you go down the stack, on the Windows side, we integrate with Visual Studio for your developer tooling. On the Linux side, we integrate with Eclipse plugins. We use Jenkins as a way of doing our builds and deployment mechanisms. There's obviously different ways of doing telemetry and writing out things inside the Linux world. And on Windows, you'd use ETW. On Linux, we'll find other systems. So there are certainly differences between them all. But we want the developer experience as much as you can from programming models and how you think about systems is very similar. Our Linux one we announced as a public preview that you can run in Azure here at Ignite as well. So you can download a Linux SDK, install that on a Ubuntu machine today. There's an Eclipse plugin. But of course, you can just write things inside VS Code if you want, or any other of your favorite tools, Vi, or whatever. We actually have Java as the first-class language on the Linux side. So the reliable services and the actors that we talked about are all now in the Java equivalent inside Linux. And yes, we'll bring the Java over to the Windows as well, but we're starting with Java inside Linux. And of course, the other thing we're excited about is that with .NET Core, you'll be able to have .NET Core apps that run both on Windows and on Linux. So we're getting quite a lot of excitement of people saying, I love the world now, I can transition those types of apps. Yeah. But the Linux one is going to be taking a few more months to get in place. By the time we get to the end of this year, we might have what we call the standalone on-premise version as a preview, and then you'll see the final GA of that happen next year.
Okay, so we're not at a GA right now. This is a public preview right now that people can go play with and everything. All right, very cool. Is there anything else that you think you'd like to share with them before we start talking about where they can get more information? Anything else you'd like to share with our listeners you think would help them understand what Service Fabric is and what they should take a look at? Why should they consider for a new application that they're building, or if they're looking to take an existing application and to modernize it or anything? Is this what kinds of things should they be looking at?
Well, I think this all comes down to, as you as a company, what are the things that you're trying to achieve that are business problems for you today? What we're seeing with a lot of enterprises today is they're choosing to move to the cloud. And, they do their lift and shift strategies to begin with. But in time, they usually run against one of these two problems: agility of how I roll out changes and how I deal with scale. And when you hit that wall and understand what it means, you then look to things like orchestrators and containers. We want to have this on-ramp where the first step might be you just want to containerize all your apps and use it as an orchestrator. Great, you can use Service Fabric for that. But we also want to go to the developer model as well, where you provide out-of-the-box programming models. We want other people we're going to open source our programming models as hopefully towards the end of this year. We want other people to start building their frameworks on top of Service Fabric. We want them to bring their languages. We're already working with a third party to bring JavaScript to the platform. We want to have all sorts of other programming models. I'd love it nothing more than one of your readers wants to implement Python as a language. It would be fantastic. Go, you name the programming languages. We want Node.js to be first class and that sort of thing. So we want to develop this ecosystem of developers where you start to think about how I build modern cloud-native applications where they run at scale. I don't care about machine failures. I don't care process failures. And I'm able to have a service that truly runs natively in the cloud.
That's interesting you said that some of the other languages. I know that Go is a very popular one, like in the container space, mainly because that's what Docker's written in. And I know a lot of the people who are building stuff to hook into Docker all seem to be favoring Go and play with it a little bit. It's an interesting language. I've come from the C# days, the classic ASP days, and then more recently spending a lot more time on the Node.js side and everything. So Go's an interesting one. .NET Core is interesting. It's really cool. All the different options that we have right now, it's kind of whatever floats your boat. It's great.
We have a bank who has a whole Node.js application, and they deploy all their Node.js applications on Service Fabric. Not a piece of Service Fabric programming model in sight, but they just launched Node.js. There's a bunch of executables, and it's working beautifully for them. So I'm very excited that I'm looking for, building a developer community around all this, getting their excitement about how they can publish their services that other people could download, and basically getting engaged with how we build these cloud-native applications on orchestration engines, with container technology, with different languages and frameworks, and share all that experience together and sort of publish some of those designs. So, if there are listeners out there who've sort of built something on Service Fabric and want to share those ideas, get in contact with us. We'd like nothing more than to publish a case study and get other developers to learn from what your pain points were and features were, and please engage with us. We have the Stack Overflow forum on the MSDN forum, and we have a GitHub issues account. We look at those daily. We try to get engaged with what people are feeling the pain points and what they want next. We really want to make this a community thing of how we make things better for you to be a developer in a cloud in the cloud space.
That's awesome. Yeah, and I'd echo that too. I mean, please, if you've worked with Service Fabric, if you've built something like that, I mean, Microsoft would love to hear you. I'd love to do a case study. We would love to sit there and talk to you as well. We'd love to get you on, find out what your experiences are with it and everything. We'd love to share that. So, Mark, I really appreciate the time here. I definitely want to, before I ask you this, I definitely want to recommend the 3-part series that you had on the Cloud Cover video podcast on Channel 9. So, go back and grab those 3 episodes. The first one's roughly about an hour long. The next one was a little bit shorter, and the next one was about the same time as the second one. But they talk about it's hands-on, like hello world, building a stateless, building a stateful, using the actor model. There was stuff with containers, there was stuff with Linux. It was a great ramp up. I thought it was fantastic for people to listen to and to watch. But where else would you send people to kind of go learn more about it? What would be your call to action? And then also, how can they follow you, keep track of what you're working on as well?
Okay, yeah. So my call to action effectively is, we have an SDK that you can go and find online on. If you go to aka.ms/servicefabric, download the SDK and put it on your local dev box. We're very excited about our dev box experience. I didn't talk about this so much, but our local dev experience, we're getting all sorts of acclaim with that, because what's good about it is it's exactly the same bits running on your dev machine as running in the cloud. So unlike cloud services today inside Microsoft, we have an emulator that pretends to be the same. So there's a great dev experience that you build on your local machine. In fact, just at Ignite here, I had a couple of companies come up to me and say, like, your dev experience alone just helps me build these apps and run in the cloud. So download the SDK.
I'll echo that. I mean, I'm sorry to interrupt you. I'm going to echo that because I think this is a good problem to have. But when I was following what you guys were doing with the Cloud Cover episode, I had a hard time following. Were you in Azure or were you doing it on the local box? I have to keep looking up and I zoom in on the video and go, okay, local host. Okay, we're still local, but it doesn't. I mean, that's the thing. When you jump back and forth, you couldn't tell the difference.
Yeah. You can have a cluster on your machine with your local one. It could be on a Windows Server machine, or it could be in Azure. And the great thing is you write your app and you just point to those different targets.
Yeah, and it was a local 5-node cluster. It emulates a 5-node cluster essentially, on your machine. So it looks like you're working with a cluster up in the cloud.
So. And then just recently on Microsoft Virtual Academy, if you go to Microsoft Virtual Academy and search for that, and you search for Service Fabric, we have Jeffrey Richter on our team. He's fairly well known in the .NET world, and he's just published a series of courses, like an 11-hour course, end-to-end education on Service Fabric, right from the very roots, taking you through the developer stack, and it's a great course to listen to. I would also encourage, if you go onto our team blog, on Service Fabric team blog, we published a little lab on there, a getting started lab, of how to build your first end-to-end sort of Service Fabric service using our Reliable Services API. Great little lab to run through, combined with Jeffrey's talks around all of that. And then as you graduate past all of that, there's content actually from Ignite that's worth listening to. And then if you search through Azure samples, we have a lot of getting started samples inside there that cover both the active programming model, the reliable services programming model, and we'll also be putting up new ones in there that just do container deployment, just a simple applications like containers to show how that all works. So sort of graduate to those larger samples. Where we're trying to go actually is to produce sort of more end-to-end solutions for particular verticals. And the one that we're focusing on to begin with is IoT. So we've just published also into the Azure samples. You'll see an IoT end-to-end sample there that hooks up with IoT Event Hub. Another one we're going to be focusing on fairly soon is building a gaming sample where you build. Interestingly, we have a lot of gaming companies building on Service Fabric.
That was that was the big demo from the Build conference, I think, right? It was
Age of Ascent.
Age of Ascent. That's right. Age of Ascent. Some of the stuff it was part of the keynote too, I believe. It was the stuff that they were showing.
Yes, in fact, we have Age of Ascent. We have a company in Europe who built one called Online Football Manager that allows you to build a football team, as a soccer team, that is, as in European football. Yeah. We have actually other other gaming companies I can't mention at this moment who are also building things. So we're seeing a lot of traction there around the sort of gaming. So we're going to focus on a vertical, and then we're going to also do one around workflow management. And we also have one already, actually, we call, probably slightly misnamed, it's called the reference application that does more workflow management. But we want people to take these more of solution type things that they can use as a kickstarter rather than just individual services, kickstart in particular verticals around them all. And we're encouraging those. And in fact, on the 4th of November, Haishi Bai, who wrote this great book on Service Fabric, he was the one who did the cloud cover. And actually he promoted in the cloud cover. He's doing an 8-hour marathon, and we're going to be covering some of these solutions, which is going to be pretty exciting inside there.
And that'll be on November the 4th on Channel 9?
November the 4th, Channel 9. Get there early at 9. It's a live event that we're going to record. I'm going to be, Hashi's the main guy who's going to be doing all the work, and he's going to having various presenters come in and out at different times, touching on subjects of container orchestration, some of how we do DevOps end-to-end, build systems, how we do continuous integration, continuous deployment, how it integrates with like Visual Studio Team systems. We'll do some of these verticals around IoT. And we'll do a lot of other best practices, some of the gotchas and what it all means, to take some of the learnings of what we built internally and from some of our customers, and kind of push those out more. So it'll be a lot more than just we want to get away from just getting started now. We want to get down to the practicalities.
Very cool, very cool. Well, Mark, thank you very much for the time here. For our listeners, what we would like to know, our ask for you is that if there's anything here that you want to learn more about, if you think, this is an emerging space. We've seen this become a much more interesting space in the last 2 years or so, from all the players, Microsoft, everybody included. Service Fabric is one of those players. It's been very interesting to see because it is the thing that runs a lot of Azure, a lot of Microsoft under the covers. So if there's anything else you want to dive into, anything else you want us to talk about and stuff, let us know. We can get Mark back and we can go a little bit deeper on certain things, go a little bit deeper dive here. But this is really the first episode we want to talk about with Service Fabric and kind of let everybody make sure to drive some awareness for it. So with that, Mark, thank you very much for your time.
Thank you very much. It's great being here.
Yeah, definitely. We'll make sure to link to all the sessions at Ignite. We'll put those in the show notes. I know that those are being published up on, I think, on YouTube this year. But we'll make sure the links are all up there. People can go take a look at where those are and learn more about it in certain silos, what people were talking about.
Fantastic. This can be great.
Awesome. Thank you very much.
Thank you.
Did you like this episode? Send us a tweet about it and drop us a 5-star review in iTunes. Word of mouth recommendations are the most effective ways for us to grow the show. We'd really appreciate it. If you have a question for us, go to microsoftcloudshow.com/questions, where you can submit it as text or record it as a WAV or an MP3 and provide a link so that we can play your question on the show. Our theme music is an excerpt from Evaporated Air by Monk Turner, used under Creative Commons. You can subscribe to us in iTunes and the Google Play Store by searching for Microsoft Cloud Show or via RSS at microsoftcloudshow.com, where you'll also find show notes of each episode. You can also find us on Facebook, searching for Microsoft Cloud Show, or on Twitter at MS Cloud Show. And finally, sign up to our mailing list by heading to our website and entering your email to interact with us, participate in upcoming interviews, and other cool stuff. Thanks for listening. We'll see you next time.